Today's video is on Introduction to Polynomials. It's something we've reviewed before, but we're just going to go back over. So our key vocabulary word is polynomial, which you'll see in purple here. I kind of created my own definition up here, but you can feel free to define it however you want, kind of take ownership of your learning. I'm going to zoom in on the characteristics that make something a polynomial. Polynomials are always made up of constants, variables, and exponents. It could be one, it could be both, it could be all three, any combination. Your exponents must be positive whole numbers, so no fractions, no decimals, no negative, and no imaginary. Actually, I should have put that in there. You cannot divide by a variable. The variable can be on the top in the numerator, or it can be out to the side, but it cannot be in the denominator. And you cannot have something with infinite terms. So I included a couple of examples and non-examples. So for our examples, you'll see that they have a constant, a variable, an exponent, combinations of all of the for example, this one right here is just variables. This would be one term. But I want you to see this one right here. So if you have 4x divided by 3, that's the same thing as 4 over 3 times x. Those are both polynomials. However, if it was 4 divided by 3x, that is not a polynomial because this x is in the denominator. So please be very careful when you're looking at those. So I've got a couple of other non-examples. Any square roots, any radicals are not polynomials because the way that we could write those is as exponents as fractions. We can't have exponents that are negative. We can't have variables in the denominator. And we cannot have variables in the exponent. That would create infinite terms that we cannot have. So if you look at the bottom here, we've got several examples. So it wants us to circle ones that are polynomials and put an X over the ones that are not. I'm going to go ahead and start with the ones that are not. So one thing that I know is that I cannot have a fraction or a decimal in my exponent. So I can go ahead and eliminate this one right here. I also know that I cannot have a radical. So that one can go. I cannot have a variable in the exponent, so that one can go. I cannot have a variable in the denominator, so this one over here, not a polynomial. And then the last one, this is one that would give you infinite terms. So this could not be, that's an absolute value. We don't talk about that a whole lot, but it is there. So that means that the rest of these should be. So I'm going to kind of look. I've got 3x to the fourth. I don't have any rules that are being broken, so that one's fine. This one has a fraction, but it's out front. It's not part of the exponent, so that's fine. Same thing here. I've got a decimal, but it is part of the coefficient, not the exponent, so that's fine. And then these are just pretty standard polynomials right there. So now we're going to kind of review the degree. So the degree of a monomial, which we can also call the degree of a term because that means it would be the only one there. We're going to add up the exponents. So we're going to take the sum of the exponents of each variable. Now for a polynomial with more than one term, because technically a monomial is a polynomial, but a polynomial with more than one term, it is the highest exponent or sum of exponents. for a single term. So we'll kind of look at some examples of those. And then the last thing we want to review is that standard form of a polynomial, we're putting the terms in decreasing order by degree. So highest degree to lowest degree. And the lowest degree that we'll have in a polynomial will always be the constant. We can't have a negative exponent. So if we come over here to the right, we've just got kind of a review. So degree of a term, a single term, you're going to add up the exponents. If it is something like 6x to the 8th power, there's only one exponent, so the degree is 8. That's a really simple one. However, if we've got something like negative 2x to the 6th, y to the 3rd, z, I have to add up all of those. So I'm going to add 6 plus 3. The important thing to remember here is plus the 1 from my z, because we don't usually write that exponent. So I would add all of those together, and it would give me a value of 10. And then for a constant, my degree is always 0, because you can think of this as having x to the 0, and anything to the 0 power is 1. For polynomials, we're going to take the highest degree of terms, so you're going to need to look at all terms and figure out which one has the highest degree. So this first one, there's only one exponent, so the degree is 5. For the second one, we are adding all of these together, and remember that this is a 1, so that gave me a degree of 10. And then this last one, we're adding together and getting a degree of 11. So 11 is higher than 10 or 5, so that would be the degree of that polynomial. Another thing to note is if you wrote this in standard form, we would put it from highest degree to lowest degree. So for standard form, we're going to write x to the 5th, y squared, z to the 4th. Then the next one will be our degree 10, so minus 2x to the 6th, y to the 3rd, z. And then finally our degree 5, so plus 2x to the 5th. So now we're going to do some examples finding the degree of the monomial. Monomials are nice because we just add up the exponents. So z to the 6th, that one's easy. There's only one, so my degree is 6. For 4a squared b, remember this is basically b to the 1st. So I'm taking 2 plus 1, that gives me a degree of 3. 7 is a constant. So constant means the degree is 0. And this last one, 5x cubed, y squared. I'm going to take 3 plus 2, and that gives me a degree of 5. Right, the last thing we're going to look at here is polynomials are, they're named according to their degree and according to their number of terms. So for this first one, we're going to look at the degree name. So if the degree is 0, 1, 2, 3, 4, 5, or 6 plus, anything higher than 6. So if the degree is 0, that's called a constant. And an example of that would be any number. It could be positive, could be negative, but just some number. When we have a degree of 1, that is a linear polynomial. So that would be something like 7x plus 3. A degree of 2 is going to be a quadratic. Typically, we see that as something like 3x squared minus 5x plus 4. All right, 3, we don't usually talk about these. 3 is a cubic function. Think about you're cubing something. So 4x cubed minus 2x squared plus 4x would be a cubic function. For 4, that's called quartic. Think about a quarter is 1/4 of a dollar. So that would be anything to the 4th power. So x to the 4th minus 9. Five is quintic. So that would be an exponent of 5. And then anything higher than that, you would just call it by its number, the 6th, the 7th, etc. And so it would have whatever that degree is, something to the 6th, something to the 7th, etc. So that's naming it by degree. We can also name it by the number of terms. And I always remember that terms are separated by a plus or a minus sign. So we can have 1, 2, 3, or 4 plus. One term is called a monomial. So an example of that would be like 3x to the 4th, or even a constant like 7. Binomial, bi means 2. So it would have 2 terms. Now this has nothing to do with the degree. This is just how many terms are actually there. For a term, when there are 3 terms, it's a trinomial. So I could have x squared minus 8x plus 9. That would be a trinomial. And then 4 or more is a polynomial. Now technically all of these are polynomials. However, we have more specific names when they have 1, 2, or 3 terms. So a polynomial is going to have 4 or more terms. One thing I want to mention down here, something we have talked about, but it's been a while, is the leading coefficient. The leading coefficient, so we call that LC, goes in front of the highest degree term. So the nice thing is, when this is in standard form, it's going to be literally your leading coefficient, the very first coefficient you have. If it's not in standard form, then you need to write it in standard form so that you can more easily find it. So our last example, we've got, I think, 2 of them. We're going to rewrite them in standard form. We're going to identify the leading coefficient, which again, we're going to abbreviate LC. The degree, I'm going to abbreviate D. And the number of terms, which I'm going to use what y'all call the hashtag, but it's actually a number sign. All right, so first I'm going to write this in standard form. So highest degree to lowest degree. So this one has a degree of 2. This one has a degree of 0. and this one has a degree of 4, so we're going to start off with that one. So this is going to be 8x to the 4th. My next highest degree is this 3x squared, so plus 3x squared. And then my lowest degree is my constant, minus 4. My leading coefficient goes in front of my highest term, so my leading coefficient is 8. My degree goes with my leading coefficient, or sorry, with my first term. So my degree here is 4. And the number of terms, I just literally count them. 1, 2, 3. Now it wants me to name this. So I'm going to name this using my number of terms and my degree. We always want to start with our degree when we're naming these. So my degree is 4, so I'm going to come up to my table. 4 is quartic. Then I'm going to look at my number of terms. So my number of terms is 3. So my table tells me that is a trinomial. So the whole name would be a quartic trinomial. Right, let's do that again for this one over here. So I've got negative 18x squared, the degree there is 2, plus x cubed, the degree there is 3, minus 5, the degree there is 0, and plus 2x, the degree there is 1. So for my standard form, I start with the highest degree, which is my x cubed term. Then my next highest degree is minus 18x squared. Then my next highest is that plus 2x. And my final one is my constant, minus 5. My leading coefficient is what comes in front of this term. I don't have anything written. It's an understood 1 out in front. So my leading coefficient is going to be 1. My degree is the exponent that goes with my first term. So in this case, 3. And my number of terms, I've got 1, 2, 3, 4. So I have 4 terms. So when I name this, again, I'm going to start with my degree. Degree of 3 is a cubic function. And then I have 4 terms. So 4 or more terms we just call a polynomial. So this is a cubic polynomial.